students, this is a preview of your Quiz 7 to help you get started. This is a great quiz because it has 6 questions, which means there are 2 freebies. So I'm going to go through each of the 6 questions and get you started and explain how to answer each one. So for the first type of question, we're dealing with domain of functions. When you're trying to find the domain of a function, you're going to start with all of the real numbers, but then you're going to restrict your domain based on what the function contains. And this first one has a square root, which always has to be greater than or equal to 0. That's because you can never have a negative inside a square root. It also has a fraction with a denominator, and the denominator of a fraction can never equal 0. So you're going to restrict your domain so that these two things will be true. The denominator can't be 0, and the numerator can't. It has to be greater than or equal to 0. For the second part, we're dealing with a rational expression with a denominator. So again, the bottom just can't be equal to 0. So figure out what x values make that happen. And 2 and 3 are the same problem. Basically, you're just going to write your answer 2 different ways. Here, we're going to list the x values that would make the denominator 0. And then to write it in set notation, we need the set of all x in the real numbers such that, and then you're basically just going to put the answer from part 2 right here. So x does not equal, and then whatever those values were. The next question is also about domain, but this time we're given a picture of a graph. Now, I do want to point something out real quick. Typically, we're used to dealing with, continuous functions like this, where your domain is going to be all of the x values. So all of these x values going in both directions forever would be part of our domain. But this is a very different type of function. We just have discrete values. So if I were to mark all of the x values that this function contains, it would be these things. These are all discrete values. So for your domain, you really just have to list numbers. Comma, comma, each number that's a part of your domain with commas in between. The range is going to be very similar, but this time we're looking at our y values, y value, y value, y value, etc. So you're just going to list all of the y values in your range. The next part is just asking us to find values. So they give us an x and they want us to find a y. They give us an x, they want us to find a y. And then they give us a y and they want us to find an x. So that shouldn't be too bad. Finally, they're asking you to identify whether this is a function. And I might have given that away because I think I called it a function a few minutes ago. We'll want to use the vertical line test to determine whether this is a function or not. It's probably the easiest way to do it. Moving on to part 3. In this problem, we're looking for even or odd symmetry. The way to do that is to start with your function, and instead of plugging in x, we're going to plug in negative x. Once you do that, you're going to compare the end point to the starting point. So what did you end up with when you plugged in negative x versus what you started with? If they are exactly the same, the starting point and the ending point, that means we're dealing with an even function, which is symmetrical over the x-axis. Symmetrical over the y-axis. If they are exactly negatives of each other, then we're dealing with an odd function, which would be a rotation 180 degrees. So really quick, I'm going to do an example. If we started with something like 5x cubed plus 3x, and when we plug in negative x, we end up with negative 5x cubed minus 3x, these are exact opposites because we started with a plus, end with a minus, start with a plus, end in a minus. That would be odd. If instead we started with, 2x squared minus 4, and we ended up with 2x squared minus 4, these are exactly the same. We started with pluses here, ended with pluses, started with minuses, ended with minuses. This would be even. And finally, if we started with something like 4x cubed, let's make that negative 4x cubed plus 3x squared, and we ended with positive 4x cubed plus 3x squared, this is going to be neither. We started with a negative and ended with a positive, so these obviously aren't exactly the same, but they're also not exact opposites because this plus didn't change. So this would be neither. Just a few quick examples to kind of show you the type of thing you're looking for. For number 4, you can kind of ignore the first part of each of these questions and just focus on whatever your interval is. Here, 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 and here. We're going to convert these intervals into set notation. So you're going to do the set of all x in the reals, and then some of these will contain a such that. Whoops. Set of all x in the reals such that, and then set builder notation will use symbols like this, or this, or this, or this, or sometimes this, the not equal sign. So set builder notation is going to have symbols like that where we describe our x's. X in the reals, such that, and then you're going to have all kinds of symbols in here. And it's up to you to decide really what you need to be using. Obviously, you're not going to use all of those. Just pick the ones that are most appropriate. Make sure you get your sets labeled properly. For number 5, this one is another graphical image where we're looking for a domain and range and some values here. So to start, we're given an x value and we want to find a y value. Given another x value, we want to find the y value. And then we're given a y value and we want to find an x value. For domain, I'm going to use a different color here. For domain, we want to find all of the x values that this function contains. So that's going to be all of these. And first we'll write it as an interval, so something like this. And next we'll write it as a set, so the set of all x in the reals, such that, and then have your set there. Range, very similar. We want all of the y values. Well, red was a poor choice. I guess we'll just use blue. All of these y values, and it looks like these are going to go up forever, so we'll have an arrow going up forever. And when we write it in interval notation, I want you to be very, 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 very careful. Of course, our values always go from low to high. We always put the smaller value on the left, right? Like here we would go from the low value to the high value with our domain. It works the same way with range, low to high. I had quite a few students ask me questions about this. For their interval notation, they got their values backward. So we would need to go from the smaller value up to the larger value. Make sure you don't get that mixed up. Many students were starting here and ending here. That's going to get you the wrong answer. All right. Finally, set notation. We're going to do the set of all x in the reals, such that, and then whatever your set is. Last question. This is a plug and chug question, but it's got 3 parts, and the third part is a little complicated. So whenever I'm dealing with plugging things in for a function, I like to rewrite my function, but leave a blank anywhere I had an x. So I would rewrite f of x equals negative 6x squared minus 9x minus 5, but notice the blanks instead of the x's. Then for the first part of the question, we're just going to plug in negative 5, negative 5, negative 5, and simplify. That one shouldn't be too bad. For the second part of the question, we're going to plug in t minus 4. And this one's going to require quite a bit of simplification. One thing I do want to point out is that this expression will need to be expanded out to look like this so that you can FOIL these. So that'll be part of your simplification process for the second part. And then the last part is the most complicated. So first we want to find f of x plus h. That's going to require us to plug in x plus h, x plus h, x plus h, and then simplify this, which is going to take quite a few steps. Once you've done that, you take this simplified expression and plug it into your difference quotient right here on the top. Then, for the f of x, we're just going to take our starting equation, plug it in right here. And finally, we put that over h, and then you simplify. A lot of things should cancel. A lot of things should cancel here. If you don't have a bunch of stuff that cancels each other out, you've probably made an arithmetic mistake and you need to go back and check your work. And that's a wrap. Hopefully at this point you feel prepared to begin your quiz 7. Keep in mind that the initial deadline, the one you should be aiming for, is this coming Friday. That's if you want to give me enough time to get you some feedback so that you can make corrections before your final deadline, which is next Wednesday. So best of luck. I hope you all do great.